We're going to be solving basic rate problems by setting up multiplications with unit analysis. And there's a lot going on there. That seems like there's a lot of things that maybe seem a little bit far-fetched and unknown, but we're going to talk about what is really going on here. All right, so we start with a basic problem like this. It says that Manuel is running at a rate of 8.5 miles per hour during a cross-country meet. If the race takes him 1.7 hours, how long was the race? And so when we see a problem like this, there's a lot of information that we can immediately pull out. All right, and the first thing that we can pull out is that we're given a rate. The rate we can find here is 8.5 miles per hour. So I'm going to come down here and I'm going to write that rate, 8.5 miles per hour. And you can actually write that rate two different ways. All right, so it's the same relationship to also say that for every 1 hour, you can run 8.5 miles. Now, when we talk about wanting to graph this, perhaps we want to consider which would be our change in y and which would be our change in x. But at this point, we just want to discuss this idea that we can say or talk about any rate in two different ways. I can say for 8.5 miles, it would take him 1 hour, or I can say if he runs for 1 hour, he'll run 8.5 miles. They all mean the same thing. It's that same relationship. All right? When I talk about a situation, I'm talking about exactly what we're trying to figure out here. All right? And so here we can see we have more information here. We're talking about 1.7 hours. This is the situation we're trying to find more out about. We're saying, hey, if he runs for 1.7 hours, tell me more, how many miles can he run? So this question says, how long is the race? So we're just going to write down here really quickly that this is a rate problem. But then we're focusing in on here, an answer sentence. How long is the race? The really important thing about the answer sentence is to make you focus in on what the units of your answer are. So in a lot of different ways, it doesn't need to be a totally complete sentence, but it definitely needs to have units on your answers. So the way that we're going to write this is the race was blank miles long. And so here's the way that you used to do this. You used to say, hey, I've got to set up this proportion. I have 8.5 miles for 1 hour, bless you. And I have 1.7 hours. And I need to find out how many miles. And so you would cross multiply. You'd get x is equal to 8.5 times 1.7 because we cross multiply over there. And this is one way to set up this problem. It's a proportion. You can set it up this way. However, what proportions don't exactly always do a really good job for us is give us a quick way to set up an equation. Realistically, if we wanted to write this as an equation, we might write it as, for our answer, we want to know how many miles. So for y miles, he's running 8.5. And it looks like I'm multiplying by the number of hours. And that's a way we could quickly set up this as an equation to figure out, hey, what if it was 2.2 miles? What if it was 2.3 miles? What if it was 2.4 miles? I don't have to set up this proportion and cross-multiply every time. I can really set up this equation like this. Crystal. So this is the new way of doing it. This is going to use unit analysis. In other words, we're going to use the units to help set up a multiplication. Because in rate problems, sometimes they're going to be multiplications and sometimes they're going to be divisions. It kind of has to depend. And what we need to do is we need to set up a way to A, figure out what that is, and B, at the same time, we're going to set it up in such a way that it's going to make it easy to write equations from word problems in the future. So, looking at this, the first thing that I recognize here is the units of my answer, is miles. So I know that I want the units of my answer over here. So this is going to look a little bit weird because we're going to put our answer on the left. And this is mainly to set us up for thinking about this as an equation, y equals m times x, where y is kind of our answer, all right? It's like we're solving for y. We're trying to figure out y. And what that means is as I'm coming over here, I want to pick out one of these rates. And I see that my answer has the miles on top, so I'm going to use this rate. And again, the reason why I used that version of the rate was because it gave me a match for my units. All right? I set it up that way. I used this rate because it gave me a match for my units. This is 100% about paying attention to the units. So if you're not thinking about the units right now, then you're not setting it up correctly. All right? And so what that also shows me is that I have these extra hours over here, and those units aren't over here in my answer. So I need to find a way to get rid of them. And so what I can do is I can take my situation down here, 1.7 hours, and I can plug it in on top. And what that does for me is we talked about this idea of being able to cross-cancel. And you can cross-cancel units as well. So what I see here is this cross-cancels my units to get rid of those extra units that I don't want. And this just gives us an idea of how we want to set up this rate, how we want to set up this as a possible slope problem to make sure that we have everything right. So we could solve for an infinite number of miles with an infinite number of hours given this rate by thinking about this as the equation, y equals 8.5x. And that's kind of the next step. Today I really want to focus in on being able to set it up with our rate correct to get our answer. So what this tells us is that when we actually get ready to solve this, all we really need to do is what? Jefferson. Yeah. Top times top, bottom times bottom. Well, there's 1 times nothing on the bottom, so that's just going to give me 1. And so all we're really doing is multiplying 8.5 times 1.7. 5 carry the 3, 56 is 59, 0, 5, 8. It looks like I'm going to get 14.45 miles. Oops, 14.45 miles. So again, I know 100% of you could have solved that problem using a proportion or guessing that it was a multiplication problem. But I don't want to guess anymore, and I don't want us to rely on proportions because proportions, in my mind, for things like this and for other skills are very slow. All right, so let's look over here. So I wanted to take all of the reading of word problems kind of out of the work for today. I wanted to focus mainly on being able to set things up so you can see that I've already basically pulled all of this information out of a word problem. So we could kind of imagine this word problem as saying, hey, somebody makes $36 in 3 hours. So I've written that rate 2 different ways. $36 for 3 hours of work, or in 3 hours of work he makes $36. It's the same thing. Situation here, so the question's asking me, if he works 18 hours, how much money would he earn? So they've given us all of the information that we need here, kind of already pulled out of a word problem. So super simplified. All right. Over here, I know that this is where I want my answer to be, and it tells me down here in my answer sentence that I need the units of my answer to be in dollars. So the question is, which of these two sets of which of these two rates do I need to use? Do I want to use the first one, or do I want to use the second one if I want to match up my units? Show me with your fingers. Do I want to use the first one or the second one if I want to match up my units? Okay, you should be showing me a 1 right now because we recognize that we want the dollars to be on top out of our rate. $36 for 3 hours. All right, so what's the problem with my units right now? I need my units to be just in dollars, but over here I've got dollars and hours. What's the problem? What's wrong with the units that I have over here on the right side? Crystal? Yeah, the bottom has hours over here, and the bottom isn't supposed to have hours over here, so we have to find a way to cancel that out. Is it here?
On the bottom part, you should put the other hours.
Yeah, so we've got this situation. The one that we're talking about is 18 hours. And what this is going to allow us to do is to cancel out our units. And it gets everything all set up nice and cozy. And the other great thing about this, and this is why I love doing this rather than doing proportions, is because for me, this makes it a whole lot easier to recognize that I don't have to do all of this multiplication all at once and then divide. There's definitely some factoring I can do here before I cross cancel. So I can cross cancel and then multiply. So here I'm thinking about this 18. I'm saying, hey, this is the same thing as 6 times 3. That allows me to also cross cancel the 3 and the 3. And now I see that this problem is not this multiplication of 36 times 18 and then having divide by 3. Really, all I need to do is multiply what?
36 times 18.
36 times what's left over after the cross canceling? 6. So yes, you absolutely could have multiplied and then divided, which is exactly what you would have had to have done if you had set this up as a proportion. But what we see here is that when we do it like this, we recognize earlier that we can do some factoring to save ourselves some work. There's 3, it's going to be 18, 21, $216. So down here in our answer choice, $216. All right. Last one. All right. So again, we see this this relationship that's been pulled out of some problem. There's a relationship between how many grams something weighs and how many, I guess, centimeters long it is. We're looking to find out, I guess, how many centimeters something would be if it was 450 grams. And actually, this looks like it's a spring problem, so we're looking how many centimeters a spring would stretch if a weight of 450 grams was added to it. All right? So that's a linear relationship. So what are my units that I want to put up here on my answer side? What are the units that I want to put up here on my answer side? This is going to come from our answer sentence. In a word problem, it's going to be coming from knowing what the units of our answer are. Jesselyn? Centimeters. All right. So I'm going to come up here. I'm going to put centimeters up here. In this particular case, which of the two rates do I want to use? The first one or the second one? Do I want to use the first one or the second one to match up my units? Still looking for a couple people to respond here. I want to make sure that we're all on track before we move on to our together time. Which of these two rates do I want to use? This one or this one? 1 or 2? Which one's going to match up our units? Okay, you should be showing me a 1 because that's going to be the one that gets our centimeters on top. So this is 2 centimeters for 50 grams. And again, I see the same problem with my units. What is the problem with my units? What doesn't match up between the two sides of my equation? What doesn't match up between my two sides of the equation? The grams on the other side. So I've got this situation that I'm trying to figure out. And who knows, they could have said this was X grams. Doesn't really matter. In this particular case, they're giving us something to solve, 450 grams. And this proves to us that everything's going to be okay here. We can cancel out these two sets of grams. And we see this. Now, once again, we could do this as we could multiply 2 times 450. We would get 900. And then we would have to divide 900 by 50. But I can do some factoring and simplify this first. Zahir. All right, so Zahir is saying that he's going to take this 450 and he's going to simplify it, or sorry, factor it. So it's 9 times 50. Why is that so useful? Why is factoring 450 to 9 times 50 so useful? William. Yep, now we can cross cancel the 50s, and we see that this is really just a multiplication of 2 times 9, which tells us the spring would stretch 18 centimeters.